Bernoulli's theorem and its applications. Daniel Bernoulli, a Swiss mathematician and physicist, stated a theorem which gives the interaction between the pressure acting at a point on the surface of the liquid and the velocity of its particles. Bernoulli's theorem states that the total energy of a small amount of an incompressible liquid flowing from one point to another remains constant throughout the displacement. The illustration shown here will help you understand Bernoulli's theorem. Motion of a ping-pong ball. Place a ping-pong ball in an upward stream of water as shown here. We observe that when a continuous stream of water gushes out of the nozzle, the ball rises to a certain height above the nozzle and stays at that height against the gravitational pull and starts spinning. We also observe that in case the ball moves to one side, it is automatically brought back to the original position. How does this happen? Suppose the ball moves towards the left. The ball continues to spin due to the liquid on the right side. The direction of spin of the ball is in such a way that the fluid velocity is more on its right side and less on the left side of the ball. According to Bernoulli's theorem, the pressure of the fluid on the right is less than that on the left. Due to this difference in pressure, the ball returns to its original position. Rise of oil in a narrow tube. Shown here is a horizontal tube AB dipped in oil. The area of cross-section of the tube at C is much smaller than that at A and B. Observe the movement of water when it is flowing from A to B. At the narrow end C, the velocity of the water increases and hence the pressure at that point decreases below the atmospheric pressure. Due to the difference in pressure, the oil rises into the vertical tube. Applications of Bernoulli's theorem. The principle underlying the working of atomizer, Bunsen burner, flow meter, and aerofoil is Bernoulli's principle. Atomizer is an instrument used for spraying perfumes and water. The experiment shown here gives the principle underlying the working of an atomizer. Displayed here is the arrangement used in an atomizer. When the rubber bulb B is squeezed, the air flows through the tube T and comes out of the narrow aperture O of the tube. As the aperture is narrow, the velocity of the air increases as it comes out. This reduces the pressure in the vicinity of O. Due to the difference in pressure, the liquid rises up into the vertical tube. But the stream of air coming out of the tube T blows the liquid into a fine spray. So next time you use perfume or deodorant, remember this principle. Bunsen burner. One of the most commonly used appliances based on Bernoulli's theorem is the Bunsen burner. In a Bunsen burner, when the gas emerges out of the nozzle, the velocity of the gas increases and as a result, a region of low pressure is created around the nozzle. As a result, the atmospheric air flows towards the burner and the air necessary for combustion is sucked through the holes present on the burner. Working of flow meter and aerofoil are also based on Bernoulli's theorem.